WizitUp.
The classifications based on elements and compound. Now, elements can be classified into metals, non-metals, and metalloids. The metals are those elements that easily give out electrons. All right, they easily donate electrons. Good examples include zinc, calcium, magnesium, aluminium. These are metallic elements. All right, and then the non-metals are those elements that usually accept or gain electron. We can represent them this way: X plus electrons. These are non-metals, although when they do that, they form negatively charged ion, or what you call anions. Anions. Okay? Whereas for the metals, they are those elements that can easily lose electrons to form positively charged ions, or what you call cations. Cations. All right? Well, we can also say, we can represent it this way, that X may lose electron to give us a positively charged ion in this way. So these two equations are the same. All right? This shows that the atom X, or the metal, loses electron to form a positively charged ion. All right? Now remember, this is because of the deficit of electron. Electrons are negatively charged. We're going to come to that, and discuss more issues about, on electrons. Now, so when an element gains electron, of course, it's a non-metal. All right? There are other properties that we're going to come across later under the periodic table. Okay. Now, the metalloids. Metalloids are elements which are between. They have properties intermediate between those of metals and the non-metals. Examples include germanium. In other words, metals are good conductors of heat. Metals are ductile. You can draw metals into wires, okay, into thin wires. You can beat metals, they are malleable. Non-metals are not. They don't have all these characteristics. But we are now saying that metalloids are in between. So they have properties which are intermediate between those of metals and non-metals. In other words, they are semiconductors. Metals conduct so well, non-metals do not conduct. Then metalloids are in between. So they conduct just slightly, okay? So we call them semiconductors. Now, elements and compounds are regarded as pure substances, while mixtures are regarded as impure substances. Now, what does that mean? It simply means that, from what I said earlier, that elements and compounds are homogeneous. They are not contaminated. Okay? Now, if the boiling point of a substance, say a compound like water, changes, then that means that water is no more pure. All right? Which means it contains a contaminant. All right? But a compound like water is pure. Okay? So because of that, we can say elements and compounds are pure substances. Now, the same cannot be said for mixtures. Mixtures are regarded as impure substances because they are mixed with other substances, okay, for which the components can be separated. In other words, they are not chemically bonded together, and there could be some contaminants. And as a result of that, you have to be able to look at it this way. We need to purify the mixtures. Now, the three criteria used for determining the purity of substances include melting point, boiling point, and the density of a substance. Now, a pure substance must have a fixed or a sharp boiling point. It must have a fixed or a sharp melting point, and it must have a fixed or sharp density. The moment these values or these physical properties vary, the substance is no more pure. Okay, now let's go to the effect of impurities on the boiling and melting points, or on purity of substances. Now, impurities raise the boiling points of a substance. Here we are looking at the liquids. So impurities raise the boiling points of liquids, while it lowers the melting points of solids. Now, what am I trying to say? If, for example, a substance X has a liquid, let's say X, for example, water. Water has a boiling point of 100 degrees centigrade, okay, at 760 millimeters mercury. That is at 1 STP, 1 ATM. Now, if, for example, the boiling point of liquid water is now 101, That means it contains some impurities. The impurities will raise the boiling point of a liquid. So it simply means that a pure liquid, like water, should boil at a lower temperature than an impure liquid. I'm sure that's clear to everybody. Now let's look at the case of solids. Impurities lower the melting point of solids. So let's assume that a solid X, all right, has a melting point of, let's say, 4 degrees Celsius, and it contains some impurities. The melting point will fall, so possibly to 3 degrees Celsius. In other words, impurities lower the melting point of that particular substance. So a pure solid will melt at a higher temperature than an impure solid. These are all past questions where they said a pure solid melts at a dash temperature. Of course, if it's a pure solid, it has to melt at a higher temperature than an impure solid. All right. Now, we move to the methods of separation. Since mixtures are impure substances, we need to be able to purify them. So methods of separating mixtures and purifying substances include the following. 1. Filtration. Filtration is used for separating an insoluble solid from a liquid. Used to separate an insoluble solid from a liquid. You may be asking, in which areas do we use filtration? First, let's look at the normal laboratory processes. Now, I can separate a solid like sand from water using filtration method. I just get a filter paper, all right? Put a mixture of sand and water in a container. Now, remember, the sand does not dissolve, okay? It's an insoluble substance in that case. So what happens is that I may run the two into a funnel. I may run the mixture, into a funnel. When I do that, you'll notice that the water will pass through the funnel. There's a filter paper here. The filter paper has some, it's porous. It has very tiny openings, which means this residue or the sand here cannot pass through. So what happens is that the sand will be trapped above the filter paper while the water will pass through. Okay, so in that case, I have separated the sand from water. I can also separate chalk dust from water. These are laboratory methods. Now, commercially, or let's say application, we can use filtration in brewery industry to remove some solid impurities during the process of extraction or manufacture of alcoholic drinks, or in our brewery to produce some alcoholic drinks. Now, apart from that, we can also use filtration in some areas, especially when it involves extraction of gold, okay, diamond. We can use to separate some substances from one another. So these are areas where filtration can play vital roles. Okay, now let's look at another process, sieving. Sieving is a process whereby we separate solutes of different sizes from each other. Separation of solutes with different sizes. Anytime we employ such method, we are discussing sieving. All right? Example of areas where sieving could be used, especially like in our industry. Sometimes we can use sieving in the garri industry. We see some of our mothers trying to separate the large particles of garri from the smaller particles using a sieve. All right? So that's a method of separating different particles of a mixture. Okay, so if you have large particles and you want to separate from a very small particle, you can use a sieve. Okay, and by the time you carry out the preparation, you find out that one of them will be smoother, while the other larger particles will be held behind in the sieve. Okay, now, like I said, we can use sieving in the garri industry. These are applications. You can use it in the garri industry before seal. You can use it to separate the large particles of garri from small particles. Sieving can also be used in the mining industry, especially those that could relate to diamond and gold, as the case may be. Now let's go to sublimation. let's discuss another process of separating components of a mixture. Sublimation. I said earlier that sublimation is a process whereby a solid changes directly into a gas. In other words, the solid does not pass through the liquid phase. Now, in sublimation, we can discuss or we can put the substance into a container, okay, and possibly heat. Now, a good example of a solid substance that sublimes when heated is ammonium chloride. This is a white crystalline solid. When you heat ammonium chloride, it will give us two gases, ammonia gas and hydrogen chloride gas. So that's why we say a solid changes directly into a gas through the action of heat. All right. Now, if under this condition, let's assume I apply heat here, and I have some solid ammonium chloride. At a lower temperature, the substance could change back to the solid. That's why we say that this process is reversible. The ammonium chloride will form a gas, or two gases in this case, ammonia gas and hydrogen chloride gas, which on cooling will revert back to ammonium chloride. This is a dense white fume. If you combine these two, you have dense white fumes of ammonium chloride, while if you heat, it will give us a colorless gas, the two colorless gases of ammonia and hydrogen chloride. All right. Another substance that can sublime when heated is iodine solid. The crystal of iodine, when you heat it, it will give us a violet colored iodine vapor, which when cooled again, will give us iodine solid. Iodine is a black crystalline solid. A black crystalline solid. So that is the process called sublimation. Now, application, you can use sublimation to separate a salt like common salt, sodium chloride, from any of these two substances. So if I want to separate ammonium chloride from sodium chloride, I can apply sublimation. Remember, you don't need liquids. Liquids are not expected to be used in this case. So we are discussing solid from another solid. So you can separate sand from ammonium chloride using sublimation. You can separate iodine solid from sand using sublimation. And you can separate sodium chloride from iodine using sublimation. Now from sublimation, we now go to magnetic separation. Magnetic separation is used for separating a magnetic substance from a non-magnetic substance or a non-magnetic material. Now, when we talk about a magnetic substance, we are talking about a substance that can actually be attracted to a magnet, or which can also attract a magnet. All right? For example, iron is a magnetic substance. Nickel and cobalt are also metallic elements with good magnetic properties. So now, if you bring an element such as iron, ferrum, and then with sulfur, and you are asked how you can separate the iron from the sulfur. By physical methods, you can use magnetization. You use a magnet, the magnet will attract the iron, leaving behind the sulfur. So you'll be able to separate them. But then, chemically, if you want to use a chemical process, you don't use magnetization method. All right? Well, iron and sulfur. Sulfur dissolves in carbon 4 sulfide. Carbon 4 sulfide, a chemical compound called carbon 4 sulfide. So iron does not. So in other words, you can dissolve these two. You can dissolve them in carbon 4 sulfide, where sulfur will dissolve, iron will be left and filtered off. You understand? You dissolve sulfur in the carbon 4 sulfide or methylbenzene, another chemical called methylbenzene. You dissolve the sulfur and filter off the iron. So thank you very much. And that is our magnetic separation. Now, magnetic separation, apart from being used in the lab to carry out this type of separation, you can use it in our mining industry. Okay, you can use it to remove some impurities, especially during the extraction of metals. You can use it in the diamond and maybe possibly copper and so on and so forth. You can just use it to remove magnetic you can use what you call magnetic separators to remove such impurities. You can use iron. You can remove iron from gold Okay, we can easily remove iron from gold. That's another way of separating iron from a very useful substance such as gold. All right. So in that case, we talk about magnetic separators. Okay. Now next, let's look at another method used in purifying substances and separating mixtures, and that is called centrifugation. Centrifugation. Now, what is centrifugation? Normally, centrifugation is a process which is used for separating very tiny solutes dissolved in possibly a large amount of a liquid. Now, what I mean is that in this process, the particles are so tiny that we need to subject them to possibly a high velocity. What we do in this case is that we get a mixture containing those small particles, and then put them in a centrifuge, which is a machine that is made to spin. Now we put the mixture in some test tubes, and then we spin these test tubes. As the test tubes are spinning, okay, at a very high speed, the particles will deposit. Normally, they move down and settle at the bottom of the test tubes, and they can therefore be run off or decanted out of that liquid. Now, centrifugation can be used in our hospitals, all right, to separate blood cells from the liquid plasma. We all know that blood is a component. I mean, blood contains some cells, and the liquid plasma, the pale colored, a yellow pale or a pale yellow colored liquid component of blood is called the plasma. So we can separate the suspended particles, okay, like the red blood cells. You can even separate fibrinogens, proteins, okay, from the blood plasma by using centrifugation.
WizitUp